5 laws actually. Okay, so instead of having so many laws at one go, okay, there are only 2 laws. So when you have a scalar, quite similar to differentiation, you have a scalar for differentiation, okay, you can bring out the scalar. So for example, you have 3 times a function. You can bring out the 3 and then multiply back in later, similar to differentiation. Second thing, when you add them or subtract functions, okay, you can separate them and do the integration separately. Okay, but of course this can only be done if there is no power there. Okay, there is no more power chain rule for integration. Okay, because that is more in JC level lah. Okay, for now we're going to deal with very basic integration here. Thanks, Rudy. Okay, so let's say 14.2 only got 1 page. Okay, nothing much. Okay, so I will just jump to 14.3, which is the main techniques for integration. Okay, where's my... Okay, I hope I can do this in 1.5 hours. If not, I have to use 2 hours lah. Okay, so very quickly, okay, I would like y'all to complete this table here. Okay, I would like y'all to because I remember in 14.1 when I introduced integration, I said that integration is simply the reverse of differentiation. Okay, so actually without doing any techniques, right, we should technically know what is the integration of certain functions. Why? Because if we do differentiation for differentiation of x, it simply gives us 1. This will mean that if integration is the reverse of integration is the reverse of differentiation, so I integrate 1. And that will give me x. But I have to add the plus c behind because the last lesson we said that there's always a constant behind. Because remember, sometimes you differentiate 2x plus 3. Then your answer is only 2 only, right? Where did the 3 go? Correct? So I give you an example here. What am I talking about? Why is there a need for c? It's because sometimes you differentiate certain functions like that. Okay, you differentiate 2x plus 3. Right? The answer here is 2. Correct? The answer here is 2, right? But what happens if I integrate 2? Is my answer 2x only? Really? But I differentiate 2x plus 3, I still get 2 mah. Right? So there's this unknown constant that we will need to find eventually. So for now, we will leave it as plus c. We call it an arbitrary constant. Why? Because think about it. I differentiate 2x minus 7 is also give me 2 what? Correct? I differentiate any 2x minus 7 minus 10 plus 100. I will still get 2. So when you integrate 2, you must account for the unknown constant that could be possibly there when you do the integration backwards. Okay? So for this table, very simply, if I differentiate x squared, it simply gives me 2x. Okay? So this means that if I integrate 2x, what should I get? I should just get back x squared plus c. Okay, it's just the reverse. Alright. Of course, there's a formula later, but I want to build up to the formula. From here, this is 3x squared. Okay. Then, if I integrate 3x squared, can you see it's just the reverse? I integrate the result of the differentiation. Right. So if I integrate 3x squared, I get x cubed plus c. Next, if I differentiate x to the power of 4, I get 4x cubed. Alright. And I will have in this case, I integrate 4x cubed, so I will actually get x to the power of 4 plus c. Okay? And finally, this one will be just simply this. And if I integrate that, I simply get x to the power of 5 plus c. You realize that plus c always happens because we want to just account for an unknown constant just in case. Right? Just in case. Okay? There are techniques later to solve for c, which I'll show you all later. Okay? There is a value for c. Okay, so if you write your answer as plus c, this is what we call an indefinite integral. Indefinite means it's just like that. Okay, second kind of integration is definite integration. That one don't have the plus c. Okay, that one you will find c, right, and you will find a result. So usually we will ask you, if you see a normal differentiation like that, we are asking you for indefinite integral. You must remember your plus c. I can tell you, many students can integrate very well. Integrate, but never always forget the plus c, right? 0 mile. Very easy to lose marks in integration and differentiation. Right? Just one simple careless mistake. Okay, so do you all see any pattern? Any patterns between integration and differentiation? Okay, if you see anything, do write them down. Okay, but of course we do know that the general formula for the differentiation of any power functions or terms is simply n times x to the power n minus 1. This is the differentiation, right? So what is integration then? What is the integration then? If you integrate this result, you should expect to get x to the power n plus c. Okay, but how can we actually, okay, put that into a formula for any kind of functions? Alright, so if you look carefully, if I want to integrate this guy, I actually add the power. Can you see n minus 1 to n, is it a plus 1? So I take n minus 1 plus 1, give me x to the power n. Okay, what happened to this n here? How does it disappear? I divide this entire thing by n. Okay, so the formula is very simple. If I integrate x to the power n, that means now I integrate a very simple function, okay, a simple x to the power n function. Alright, the result is simply x to the power n plus 1. You increase the power. Remember in differentiation you decrease the power? Right? So integration is the reverse. So what's the reverse of subtracting? Adding. Right? Then remember you bring down, when you do differentiation, you bring down the power, right? You bring down the O power and you multiply, right? What's the opposite of multiplication? Division, right? So now you divide. But what do you divide by? You divide by the new power. I say again, you divide by the new power n plus 1. Okay? I say again, it's a division. And then you must add the plus c. Alright, so this is your integration formula. When you integrate x to the power n, you simply add the power, x to the power n plus 1. You divide by the new added power, so n plus 1. Alright, plus c. Okay, for some of you who have already kind of like know this, okay, I do practice a bit more, okay, because quite tricky. Alright, are we putting up on Google Classroom as well a set of common O-level differentiation kind of questions? Let you see, I consolidate most of it. I think Mr. Alfred also helped me with this. Okay, let you see that actually the type of questions that will come out for O-levels. Alright, for differentiation. Okay, so now we're doing integration, so eventually there will be integration. Alright, so usually questions are quite straightforward. Find the indefinite integral of each of the following. So indefinite integral means you must have the plus c. Okay, just leave your answer as plus c. So you start by putting integration. So integration sign is like that, curly whirly, vertical curly whirly, I don't know, x squared, then write dx. Why write dx? You are telling us that you are integrating this function with respect to x. Remember in differentiation is dy over dx. That bottom dx represents the variable that you are differentiating with respect to. Alright? Sometimes in the future there can be a integration of something with dy, dt, du. Especially those taking H2 math. Okay, you need to be able to change your variables. Okay, and integrate with respect to the variables. But for secondary school, don't worry, we're only dealing with at most x or y lah. Alright? For now, we deal with x first. So to integrate this straightforwardly, x cubed divide by 3. Okay, y3, the new power is 3 lah. Okay, then add the plus c. Quite straightforward lah. Nothing too difficult. Okay, so if I give you dy over dx equals to 1, how do you integrate this? Think about it. When you have y equals to something, you differentiate, you get dy over dx. So now you got dy dx, you differentiate dy dx, what do you get? Correct. So you're going to get back y. Okay, remember, integration is the reverse of differentiation. So if differentiation brings you from y to dy dx, integration brings you back the opposite way. Dy dx back to y. Okay, so in this case, I'm going to find y. So y is equals to the integration of dy dx, which is simply 1. dx. How do you differentiate 1 when there's no variable? Totally possible. Think about it. You differentiate 2x, you get 2. So if you integrate 1, you will get back x. So this is simply x plus c. Why x? Because think about it. There is a... how does this apply to the formula? Okay, one way to look at this is that this is in fact integration of x to the power of 0. Because 1 is equals to x to the power of 0. So if I apply the formula, I increase the power by 1, right? So 0 plus 1 is x to the power of 1. So that's why there's an x divided by 1. But anything divided by 1 is just itself, and hence your answer is just x plus c. Okay, c is an arbitrary constant. What does arbitrary means? Means it can be any number. If you take the constant and multiply it by another number, it will still be c. Okay, in mathematics, we must understand that the word arbitrary means that if let's say I have c, right, I can multiply any number to c and it still remains as c. Because we don't know what is it, that's why it's called arbitrary. Okay, there's a very important difference between arbitrary constants and just constants. Okay.